Right guys, so the last video covering the foundational biomechanical concepts that I want you to get a grasp of when it comes to lifting weights is resistance curves. Now, resistance curves is a subject in which I would make sure that you have an understanding of the previous concepts first before moving into resistance curves, because that makes the concept of resistance curves, or the subject of resistance curves, really easy to get a handle on. But resistance curves essentially describes the amount of tension that's on a target muscle as you move throughout a rep. So I've given you a couple examples right here. We've got the dumbbell lateral raise and we've got the squat. Now, in previous videos, I went over moment arm, internal, external moment arm. I also talked about in a different video the various forces that apply to the body or bodies in the world. And there's a lot of different factors. We could also talk about the design of a machine, and we can get really lost in the weeds with that subject. But understand that throughout a rep, different exercises show a greater amount of tension, but then also a greater or a less great fluctuation in tension across the rep. So if we look at the resistance of, say, a lateral raise, you raise it out to the side. Both gravity is having the most amount of effect when the dumbbell is in the air, because dumbbell is being pulled to the floor by gravity, but then also the distance from the dumbbell to my shoulder is the greatest when I raise it up. So for two major reasons, that is the hardest part of the rep. So tension peaks here. So in this example with the dumbbell lateral raise, what I've done here is showing you a graph, and this just represents the resistance curve of a lateral raise, where on the left you've got the tension running up the vertical column, and the horizontal axis we've got the end ranges. So let's say the start of the rep is point A and the end of the rep is point B, okay? Start of the rep, all the way up, all the way back down, just in this example. The resistance curve would just be a spike all the way to the top where peak tension is created at the top of the rep and then just drops back down in a linear fashion, okay? That would be the resistance curve of a dumbbell lat raise. It's basically just a big spike and then straight back down again. Now, I want to show you a different example. When we look at a squat, the bar is being pulled to the ground by gravity. We know that. So that means when your joints, your knee joint and your hip joint, are furthest away from the line of force, imagine the line of force being here, when the man is parallel right here, that's where there's the greatest amount of tension in the quads and in the hips. Now, ideally with a squat, your technique would be you would come down even lower than parallel. If you come down even lower than parallel, say for example that bottom couple of inches, there's actually less tension in the bottom couple of inches as opposed to when you're parallel, okay? So that's what we want to understand here. So that actually means that as you squat down in a squat, the tension goes basically through the roof to the point where you reach parallel, but then let's say you squat all the way ass to grass, then the tension is actually going to be reduced slightly, not majorly, but slightly, as the moment arm, the external forces on the body drop a little bit, and then you would come back down, okay? So it wouldn't be this straight spike where the bottom of the rep is just peak tension. The bottom of the rep is actually not quite peak tension. Parallel is peak tension when it comes to something like a squat. So the resistance curve would be all the way up and then slightly dip and then come back down again. So those are two examples of different resistance curves, and as I said, every exercise is unique and you don't need to understand every machine and the way it's designed. You don't need to go and speak to the people who design the machines at Prime and Atlantis and Watson, have a conversation and understand their design concepts. All you need to do is be able to feel a rep and understand where the point is of greatest tension relative to the concepts I've described, and make your best estimation, because we can sit and calculate these things, but ultimately we don't need to get our protractors out in training. We just need to understand where the point of greatest tension is in a rep and understand that it's important to control movement through that point. Because you'll find, for example, and this is more practical application, in a dumbbell lateral raise again, as an example, here is really, really hard. So what you'll see everybody's technique is, in this point where we want it to be the most controlled and all the tension to be on the shoulder, because this is the hardest point, people swing up and lean back and just try and create momentum from everywhere apart from their shoulder to take tension away from the shoulder. And the idea of understanding resistance curves is understanding how to control that movement through the points where there is a gradient in tension, and understanding where the point of greatest tension is and actually maximizing your control and execution in that point in order to get the most stimulus out of the exercise. So that is a basic concept of resistance curves. Hope that makes sense.